Now what we're going to do is graph logarithms. When we're graphing these, we're going to spend a couple days on this. The first thing that we're going to do is we're going to look at easier graphs where we have a certain vertical asymptote, and the vertical asymptote that we're going to work with is just going to be x is equal to 0. The reason why is because you can't find the log of 0. So that means that we have a vertical asymptote there. Then what we're going to do is we're going to find the table of values. The two values that we're going to use is 1 and b, because we know that when we find the log of 1, it's always 0. And then whenever we have the log of b, and b being whatever our base is, then those two values make the log equal to 1. So when we're looking at our first one, what we want to do is come up with our vertical asymptote. And once again, what we're going to do this time is have all the vertical asymptotes be at x equals 0. And then when we have parentheses, we'll start seeing how it shifts left and right. For the table of values, for this one right here, our first one is going to be at 1 because the log of 1 is always 0. And then we're going to pick 3 because our base value is 3. When the bases are the same, it becomes 1. So we have our vertical asymptote at 0. We have 1, 0. We have 3, 1. And that right there gives us our graph. It's going to be an inverse of exponentials. So it looks like an exponential, except it's going up and down. I should say it's heading off to the right in this case. So looking at the next one, we have our vertical asymptote. And once again, all of these are going to be the same. So x is equal to 0. And then what we have is our table of values. And we're going to pick our value of 1 because the log of 1 is 0. And 0 minus 2 gives us negative 2. Then we're going to pick 4 because our base number is 4. And when our base numbers are the same, what's going to happen is that it's going to be 1. So 1 minus 2 gives us negative 1. We have our vertical asymptote at 0. And then what we have is 1, negative 2, and 4, and negative 1. So for the next one, once again, same steps. What we have is our vertical asymptote. And because there's no parentheses, it's always going to be the same. So x is equal to 0. Then what we have is our table of values. Once again, the first one that we want is 1 because the log of 1 is always 0, and that gives us 0 plus 1, which is 1. Then we're going to plug in a half because when the bases are the same, it gives us a 1. 1 plus 1 is 2. And this would be similar to a decay function in the exponential. Uh, what makes it a decay is when we're looking at it, what we notice is that our b value is less than 1, just like a decay for exponentials is always in between 0 and 1. Logs is the same. So for the next one, we have our vertical asymptote at x is equal to 0. And then we have our table of values. Once again, we're going to pick 1 because the log of 1 is 0. We're going to pick 5 because our base is 5, and when the bases are the same, it gives us a 1. So with this right here, we have 1, 0, we have 5, and we go to 1. So for our next one, once again, we're looking at this. We know that our vertical asymptote is going to be at 0. And then we're going to come up with our table of values. We're going to plug in a 1 whenever the log is a log of 1. Whenever we plug log 1 in for log, what we get is 0. And then we know 0 plus 4 is 4. Then I'm going to plug in a 3 because my base is 3. That gives us a 1. 1 plus 4 gives us a 5. So we have 1 and 4, and we have 3 and 5. And for our last one, we have our vertical asymptote at x is equal to 0. Then what we're going to do is we have our chart. We're going to pick 1 because the log of 1 is always 0. 0 minus 1 is negative 1. And then we're going to pick a fourth because that's our base number. Whenever we have numbers that are the same, it gives us 1. 1 minus 1 gives us 0. So we have our vertical asymptote. And then we have our points 1, negative 1, 1/4, and 0. And notice that we have another decay.